In this lesson, we are going to learn how to read histograms. A histogram and a bar graph look fairly similar, but there is a difference and a purpose for each of them. A bar graph usually has lines that are separated, and the information collected is usually not about numerical values. So for example, they're more like categories, years that something happened, favorite colors, that sort of thing. Sometimes there are spaces between each bar, sometimes there aren't, but it's not really about numbers. Whereas a histogram shows a distribution of data. The bars are continuous, they relate to each other directly and deal with numerical value. So there are no spaces in between. The reason there's a space here is because there was no data for that range of values. So histograms usually deal with a range, bar graphs are categories, histograms are numerically related. The bars on a histogram will be labeled with numbers. Each bar will include the data from the number on the lower edge of the bar. So for example, in this red one, 0 is included in there, but not the data from the number on the upper end. So basically, whatever it is that we are comparing here, 20 is not included in the red. It would be 19.99999 would be included in the red, but as soon as you hit 20, 20 is now included in the next bar. So 60 is included in the green. 80 is included in the blue, etc. So whatever that number is on the lower end, it's included to the right. So the yellow bar includes any student with a mark of exactly 40%, but does not include students with a mark of exactly 60%. So the number on the low end is included in the bar to its right. So traffic engineers watch traffic patterns to see if certain intersections need stop signs or traffic lights. An engineer installed a traffic counter to determine how many people use a particular intersection in an afternoon. His results are shown on this histogram. So we can see they're taking data every half hour is where they're collecting, and they've sorted this into. So during which time period was there the most traffic? So we look for the highest bar, and we come down, and that is between 4:30 and 5 o'clock. 4:30 p.m. to 5 o'clock had the most traffic. How many vehicles use the intersection between 5:30 and 6? So here's our 5:30 and 6. Here's our bar for that. We come over, and remember this is numbers in thousands, in hundreds. So we're between 400 and 500. It's a little over half, so we can approximate it at about 460 vehicles. How many vehicles use the intersection between 3 and 7:30? That is all of our data. So we have to figure out what is the data value of each bar and add them all together. So this is going to be an approximation because some of them we're going to be estimating between values. So we'll estimate the following: 100, 280, 305, 600, 505, 460, 480, 300, and 180 for a total of 3,210 vehicles. So that is how you can read a histogram. Let's try one more. So in research about people with disabilities, Jeff and Lisa found the following two histograms that deal with the percentage of people in the general population with disabilities. The graph on the left is males. The graph on the right is females. So what percentage of the male population between 45 and 64 has a disability? So male is on the left. Between 45 and 64, what is this value? It is approximately 18%. What percent of the female population in the same age group, so between 45 and 64, has a disability? So again, between 45 and 64, we come over, and this is about 19%. So by comparing the two histograms, we can make a general statement about the percentages of men compared to women who have disabilities. So if we look at the two histograms, what could we say? Well, women are slightly higher, but it is a very small percentage. So women are slightly, and it's at the very slight, higher. Carrie, one of Jeff and Lisa's classmates, said that she thinks that 66% of the population between 65 and 74 is disabled, and that this is a rather high percentage. Do you agree or disagree? Well, she's looking at it between the ages of 65 and 74. Each one of them is around 33%. So what she has done is she has added 33 and 33 and said 66% of the population has a disability. But what she has forgotten is how percentages are calculated. That's 33% of the male population and 33% of the female population. So if you were to actually add those together, you would also be increasing the number of people you were considering. So it still balances out, and it's still only 33% of the population. So it's a no because she has not understood, she's not understanding how percentages are calculated. Now look closely at the histograms. What two things about them could be misleading? Well, one of the things for sure is that this last group says all ages. So it looks like, if we see a trend, it looks like the trend is getting higher. So things are getting higher, and then all of a sudden there's a drastic drop-off. But that drastic drop-off is not true. That all ages is just an average. So they've thrown on an extra piece of information that is not part of the trend. So we can't actually look at it as a trend that's dropped off. They've just added the average to the end. The other thing is the scales aren't necessarily uniform. We go 15 years between 0 and 15, but then we go 10 years between 15 and 25, then it's 20 years between 25 and 40, etc. So the scales are not uniform, so it could be very misleading in that aspect as well. So now hopefully you have an idea of what a histogram looks like. It's a range of data. Remember that data that is on the left-hand side of the bar is included in the bar to the right. So now you can go and try your practice questions.